Okay, for number one on the homework, would the temperature of the surrounding water go up or down? To make this decision, the only thing I need to look at is the sign of delta H. Since the reaction's endothermic, the surroundings are going to get colder. That's something you need to memorize. For 1B, how much heat is absorbed or released by the reaction when 4.2 grams of NaCl are dissolved? I already know from the sign of delta H that the reaction's absorbing energy. Now I just need to determine how much. Again, I set up my proportion the same way every time, where in the upper left goes the heat of the reaction. Since I have 4.2 grams of NaCl, the coefficient for NaCl will go here. I'm looking for the amount of heat released when I have 4.2 grams. So off to the side here, I need to do 4.2 grams of NaCl. The molecular weight of NaCl is 58.5. So 4.2 divided by 58.5 gives me 0.0717 moles of NaCl. Now I can solve my proportion. 3.9 times 0.0717 gives me 0.28. That is the actual amount of heat released, and that is in kilojoules. Sorry, the actual amount of heat absorbed. For C, that amount of heat was transferred between the reaction and water surrounding it. What would be the final temperature? If I'm solving for the change in temperature, I'm going to use Q equals mCp delta T. Before I plug this in here, I'm going to have to convert from kilojoules to joules. So moving the decimal 3 spaces gives me 280. Mass of water is 50 grams. Specific heat of water is 4.18. And I'm solving for the change in temperature. So 280 divided by 50 and divided by 4.18 gives me a change in temperature equal to 1.3 degrees Celsius. To find the final temperature, I need to decide if I'm adding or subtracting. To make that decision, I'm going back up here to the thought I went through in 1A. Since the reaction's endothermic, it's going to make it colder. If I'm starting at 20 degrees and I get 1.3 degrees colder, I'll be subtracting, giving me 18.7 degrees Celsius.